Today we are going to learn about mastering virtual environments in Python. You'll discover how to create, activate, and manage virtual environments for seamless package installation and dependency management.
Welcome to this video on mastering virtual environments in Python. Virtual environments are an essential tool for any Python developer. They allow you to create isolated spaces within your system for specific Python projects. This isolation is crucial because it prevents conflicts between different projects' dependencies, ensuring that your code runs smoothly. By using virtual environments, you can have multiple projects on the same machine, each with its own dependencies, without them interfering with one another. This is particularly important when working on projects that require different versions of the same package. In this video, we'll delve into the benefits and practical applications of virtual environments, setting the stage for more efficient and conflict-free Python development. Virtual environments offer numerous benefits that enhance your Python development workflow. Firstly, they provide excellent dependency management. By isolating project dependencies, you can ensure that each project uses the exact version of the packages it needs. This isolation also aids in project isolation. You can work on multiple projects simultaneously without worrying about conflicts between dependencies. Additionally, virtual environments facilitate version control. You can easily switch between different versions of a package as needed for different projects. They also make environment replication straightforward. Sharing your project with others becomes easier, as they can replicate your environment using a requirements file. Finally, virtual environments simplify collaboration. By ensuring everyone on the team works within the same environment, you minimize discrepancies and project issues. These benefits make virtual environments a powerful tool in your Python development arsenal. To create a virtual environment in Python, one of the simplest tools you can use is Venv. It is a built-in module that allows you to create lightweight, isolated Python environments. To get started, navigate to your project directory in the command line or terminal. Use the command python3m venv myaf to create a new virtual environment named myaf. This command will generate a directory structure containing a copy of the Python interpreter, standard library, and a few scripts. Activating this environment is simple. On Windows, use .myaf/scripts/activate, while on Mac OS and Linux, use source myaf/bin/activate. This activation process modifies your shell session to use the environment's Python interpreter and its site packages directory. Once activated, any Python command or script you run will use the environment settings. Remember, configuring your environment settings correctly is crucial for its proper functioning. Activating a virtual environment is a key step in working within its isolated space. To activate your environment, use the activate script located in the environment scripts directory on Windows or the bin directory on Mac OS and Linux. For example, run .myaf/scripts/activate on Windows or source myaf/bin/activate on Unix-based systems. Once activated, your command line will display the environment's name, indicating you're operating within it. To deactivate the environment, simply type deactivate into the command line. This command will return you to your system's default Python environment. Switching between environments is straightforward. Deactivate the current environment and activate another. This flexibility allows you to work on multiple projects simultaneously, each with its own dependencies and settings, without conflicts.
Once your virtual environment is activated, you can install packages using pip, Python's package manager. This ensures that the packages are installed only within the environment, keeping your system clean and free of unnecessary dependencies. To install a package, use the command pip install package_name. For example, pip install requests will install the requests library in your environment. You can check the installed packages by running pip list, which will display all packages and their versions in your environment. To upgrade a package, use pip install upgrade package_name. If a package is no longer needed, uninstall it with pip uninstall package_name. This package management flexibility makes virtual environments an indispensable tool in managing Python project dependencies efficiently. Managing dependencies in larger projects can be streamlined using a requirements.txt file. This text file lists all the packages your project depends on, along with their versions. To create this file, use the pip freeze requirements.txt command. This will generate a file with all currently installed packages and their specific versions. When sharing your project with others, they can simply run pip install or requirements.txt to install all dependencies in their environment, ensuring consistency across development environments. This approach is particularly beneficial for collaborative projects, as it minimizes discrepancies between team members' setups. By using a requirements.txt file, you make your projects more portable and easier to manage, reducing the potential for errors related to missing or incorrect package versions.
Despite their usefulness, virtual environments can occasionally encounter issues. Activation errors are common, especially if the environment's path is incorrectly set or if the activation script is not executable. Ensure your paths are correct and scripts have the necessary permissions. Path conflicts can arise if multiple Python installations exist on your system. Specifying the exact path to your Python executable during environment creation can resolve this. Package installation issues may occur if dependencies conflict. Using the pip check command can identify and help resolve these conflicts. Environment corruption can happen if files within the environment are accidentally altered or deleted. In such cases, recreating the environment is often the simplest solution. Finally, resolving conflicts between different package versions is crucial to maintain a stable environment. Regularly updating your environment and dependencies can help prevent many common issues.
Adopting best practices for virtual environment usage can significantly enhance your development workflow. Start by using consistent naming conventions for your environments, making it easier to identify them at a glance. Regularly update your environments and dependencies to benefit from the latest features and security patches. Creating backups of your environments can save time if you need to restore or replicate them. Incorporating version control systems, like Git, ensures that your environment configurations are tracked and can be rolled back if necessary. Thoroughly document your dependencies and any specific configuration settings to make it easier for others to understand and use your project. Following these best practices will help you maintain efficient and reliable development environments.
In conclusion, mastering virtual environments in Python is a vital skill for any developer. Throughout this video, we've explored the creation, activation, and management of virtual environments, as well as how to effectively handle dependencies. Virtual environments not only enhance your project's organization and efficiency but also prevent conflicts, making them indispensable in professional Python development. We encourage you to continue exploring and practicing with virtual environments to fully integrate them into your workflow. Thank you for joining us in this journey to mastering Python virtual environments. Until next time, happy coding!